Determine all values of c that satisfy the conclusion of the mean value theorem for the function f of x equals x squared on the interval -3 included to 7 included. The first thing to do is to determine whether the two conditions are met for the mean value theorem to apply. The first condition, the function f of x equals x squared, has to be continuous on the closed interval given. X squared is a polynomial, and a polynomial is continuous on any interval, and therefore it'll be continuous on the given closed interval, -3 to 7. A closed interval includes both ends, therefore square brackets on both ends. So condition 1 holds. The second condition, the derivative of f of x, f prime of x, it's a power rule, bring down the power, subtract 1 from it, has to be continuous, it's called differentiable, on the open interval. 2x is also a polynomial, and a polynomial is continuous on any interval, and therefore this is continuous, it's called differentiable, on the open interval. It's always on the open interval because the endpoints of the function are technically never differentiable. So we always have the open interval indicated by the round brackets. It doesn't include either end. Condition 2 is met. Since both conditions are met, the conclusion of the mean value theorem applies, which says that f prime of c, the slope of the tangent line, equals f of b minus f of a over b minus a, the slope of the secant line between the endpoints, for some c in the open interval -3 to 7. There will be at least one c that makes this true, perhaps more. For this problem, the a and the b are defined by the interval. A is the left endpoint of the interval, -3, and b is the right endpoint of the interval, 7. This equals to f of 7 minus f of -3 divided by 7 minus a -3. F prime of c is found by plugging c into f prime of x. So the left side will be 2c. The right side will be f of 7 minus f of -3, found by plugging those into f of x. 7 squared minus -3 squared, and then divided by 7 minus a -3, which is 7 plus 3. 7 squared is a 49 minus -3 squared, which is a positive 9, over 7 plus 3, which is a 10. 49 minus 9 is a 40, divided by 10, so that 2c is equal to 40 divided by 10, which is 4. Divide both sides by 2, and c comes out to a 2. That is in the interval of -3 to 7. So we keep that result. There was guaranteed at least one value of c that makes this happen, and there's the value of c that satisfies the conclusion of the mean value theorem.